Hi there, this is Mr. Ambrose's video for class on Tuesday in Algebra 2 Trig Theory. Now, I guess for today, or for this video, I do have some good news in the fact that this will probably be the last video that you have to listen for a while. In fact, possibly even for the rest of the year. So, let's see what this is all about. In this video, I'm going to be introducing to you guys the law of sines. Now, what is this all about? Why does sine have a law? Well, we know that with the right triangle, we have a couple different ways to analyze the right triangle and its sides and perhaps angles in that right triangle. In particular, we have the Pythagorean theorem, which relates all three sides of the right triangle, and then we have SOHCAHTOA to help relate the acute angles of the right triangle to the respective sides of the triangle. But this is only true in a right triangle. What happens when we don't have a right triangle? Those particular triangles that are not right are referred to as oblique triangles, and unfortunately at the moment we don't have any particular formula or theorem that kind of helps us relate the sides and the angles of those particular triangles. So that's where the law of sines will come into play. So here we have two oblique triangles, the left one being an acute triangle and the right one being an obtuse triangle. And they're both a triangle ABC, and you see the angles and the sides labeled in both triangles. Now for Monday, and my video for Monday and on class on Monday, we worked with the new area formula for a triangle that involved trigonometry. And so you see here the three different ways we could actually write out that area formula. We have that the area could be equal to 1/2 AB sine C, or we could write it as 1/2 BC sine A, or we could write it as 1/2 AC sine B. And each of those three formulas captures the area of the triangle, with the big thing being that the respective angle is included in between the two sides in each expression. Now, because each of these captures the area of the respective triangle, or a triangle, the area of a triangle should be equal regardless of how we come about it. So that's why hopefully you're okay with the fact that I've set each of these expressions equal to each other, because they all represent the same area of each triangle. So now, to try and derive and come about what the law of sines is, what I'm going to do algebraically is, to each of these expressions, I'm going to divide by 1/2 A times B times C. And hopefully you'll be okay with me doing this, because like with any other equation, if I do the exact same thing to each side of the equation, our equation or our equality should still hold true. So now let's see what each of these expressions simplifies down to. The first expression will wind up being equal to the sine of C over just little c. The second expression will wind up simplifying down to sine of A over little a. And the last expression will simplify down to sine of B over little b. And this here, these three different ratios equal to each other, actually winds up being our law of sines. However, the way that it's presented in the Algebra 2 Trig curriculum, you will see it written just slightly differently. In the Algebra 2 Trig curriculum, the way that it's written is that essentially they just take the reciprocal of each one of these particular ratios. And hopefully you would be okay with doing this, since if we do the same exact thing to each side of this particular equality, the entire equalities should hold true. So, if we just take the reciprocal of each side of that equation and then perhaps just move them into an order that goes in alphabetical order, we would have that a over the sine of a is equal to b over the sine of b is equal to c over the sine of c. And this is our law of sines, and this is a particular relationship that allows us to relate the sides and the angles of any particular triangle, especially those triangles that are oblique. And the other thing is that when you utilize the law of sines, normally you only work with two ratios at a time. You normally don't work with all three all at once. So let's perhaps look at a problem or two. Okay, so here's an example where the law of sines would come into play. In particular, we have here an oblique triangle. Specifically, it's an acute triangle, ABC. We're given side A is equal to 11.4, side B is equal to 12.8, and angle A is equal to 58 degrees. And we're asked to solve for or find the measure of angle A. So, in this particular problem, since we have the side A and angle A, and then we also have the side B, and we're looking for angle B, we would only need to use, in the law of sines, the one ratio of A over sine A equals B over sine B. This particular proportion will ultimately help us solve for what the measure of angle B is. Now, at this point, we can substitute in the values that were given into this particular proportion. So we would have 11.4 over sine of 58 is equal to 12.8 over the sine of B. So now that we have this set up, we can try to work towards, again, trying to solve for angle B. That angle B, we see, is located over here. Now, in a similar fashion to when we worked with solving trig equations, if we're going to ultimately solve for the angle B in this case, what we really need to do first is to get the sine of B all by itself. And we can accomplish that by perhaps cross-multiplying in this particular proportion to help us get to that point. So, if we do that, we would have 11.4 sine B equals 12.8 sine of 58. And then to finish getting the sine B all by itself, we can just divide both sides by 11.4. Now, to finish off this problem, you really need the aid of a calculator. And so, if you just make sure that you are in degree mode, if you go and calculate the right-hand side of this particular equation, you'll get a decimal that would be 0.9522. When doing these types of problems, I would highly recommend that you carry this out to at least 4 decimal places. And we have now the sine of B is equal to 0.9522. Ultimately, we want to try and solve for angle B, so here's where, in particular, your inverse trig functions can help us out. Because, if you recall, the inverse trig function helps us to solve for the particular angle that satisfies this equation. Now, the only problem is that 0.9522 is not an exact value that we have. So once again, this is where your calculator is going to come into play. And if you look on your calculator, above the buttons for sine, cosine, and tangent, you'll see in blue the inverse trig notation. So that's what we want to use to help actually solve for what this angle B is. And if we therefore hit second sine on our calculator of 0.9522, we'll get the angle solution, which when rounded is 72 degrees. So this concludes this particular video. Once again, I thank you for tuning in. I hope that this was helpful to you guys, and in particular will help you with working on the problems you'll see on Tuesday. If you are wondering or getting a little concerned that we have the law of sines, and well, what about cosine or tangent? Don't fret. Cosine has its own law, which you will see a little bit later in the week. Hope you have an awesome day. Take care.